Hi, folks. Uh, Welcome. Sorry we started a little bit late, but welcome to today's Common Lisp Study Group. I'm your host, Ram Bedam from Atlanta Functional Programming. Today, we'll be discussing Chapter 9, which was a practical exercise in actually implementing macros from Practical Common Lisp. It was a nice tutorial that effectively makes you build a primitive but very effective unit testing framework. And it does this from some basic functions that you then refactor to a nice 26-line script almost. Illustrates, some of the powers are just generating these macros. So before we get to that, a couple of just quick administrative announcements. One, I do know and I do understand that we have been going through this material at a fairly quick speed. Those of you who are just joining in on us, haven't done so yet, I do encourage you to take a look at our study groups on some of the material, primarily because it will help you catch up really quickly on the Atlanta Functional Programming YouTube channel. You are on Tech 404, which is the Slack channel for the Atlanta Tech community. I have posted the YouTube channel in the functional programming Slack channel, so you guys can go and become subscribers. And all these study sessions are recorded for your own, viewing pleasure. You can, go and rewatch them at your leisure. And if you have additional topics that you want us to discuss that's outside review of that we are covering, please, let me know either via Slack or I'm on the Lisp Discord server. Just mention it on either general or on it was general or in the Common Lisp channel itself, though I do recommend trying to those kinds of requests to the general channel. So to begin, I wanted to show you guys sort of the end result and go backtrack on that, just because I feel the end result really justifies where started. In chapter 9, at the very end of the chapter, it actually a script on how to generate a basic unit testing library, and he does it in exactly 26 lines. If you see where this came from, you'll understand that my script actually does a lot more than you think. So with the result being available at our leisure, we can go through, discuss some of the things that are of probably particular confusion, especially those who have been following our start out and ask those of you that are on the Hangouts, have you guys had a chance to read through and play with chapter 9? Oh, anyone? Oh, we'll just go through it then. To start things off, just
a couple people in the group chat.
Sorry, I somebody tuning a piano in the house, so I had to run outside. Yes, I did read it.
Oh, okay. I just got it. Oh, Jacob and Travis. Okay, you just started and joined. Okay, so Jacob and Travis, welcome to our group. I do encourage you to Practical Common in its entirety online. That's what we're going through right now, and then we're going to be trying to books or even tutorials and other stuff later on. But we're starting to, go with a common foundation with everyone. So if that's the case, I'm just going to go ahead and then, go through this one by one and doing the refactoring in real time so that you guys can actually see this. But I decided as a reference to at least show you what the final bit looks like, which is the bottom buffer in the corner of my of the window that I'm presenting to you folks. By the way, is my screen visible to all you guys in a clear form, or do I need to like increase the font? Good. All right. Thank you. So let me, without further ado, clear up some things here. And let's start up a new buffer here. We'll call it Chapter 9 Practice.Lisp. To get started, let me just minimize my windows here a little bit. Give me a second. And let me just do this. Up. Let's start at the very beginning. All right. So, the basis for this unit testing framework revolves around obviously testing different types of functions. So the first very function that one would normally try and do is let's say that we're testing the adding function. Okay, and this is what was presented in the book. We create something called test plus, and you can do this because in Common Lisp the symbols you can have certain types of symbols inside the function declaration. I don't believe you could do the same in other languages. And all we're doing is we're going to test a couple of cases here. We're checking that 1 plus 2 is obviously 3. We're testing, obviously do multiple of these because the plus operator takes multiple parameters, has a rest parameter. And we can check to see if, add negative numbers and appropriately get a normal negative number. To start things off, this is a very simple function. Run this on your, see that, it's just going through each of the expressions one by one, testing if their condition is true, and obviously, and just check to see if all of them true and returns true. Anything, out of the ordinary there. But let's say that you want to now print a pass or fail, for this, because obviously, just seeing it true at the end doesn't, necessarily tell you passed and which things have failed. It's just, throwing down, a big and for each of each condition, and if everything passed, the entire test passes, or if anything fails, the test will fail. So we could then, look at a modification with the display results. I'm going to call this a different function than refactoring it right now for the time being. And we could just simply, and this is going to look a little foreign to those of you who are coming from other languages. So I'm going to explain this to you in just a minute. But this is a special syntax, much like, printf, and a little bit more powerful in that it could take the results of an expression here. If it's nil, that is, if it's false, it will say fail, and if it's true, it'll pass it. So if you look at this simple example here, and let's say that we just take and pass it. We'll grab this guy. Let's just take these two examples here that we just passed in, and we run this. So I'm just compiling the function, and then in my REPL, try to display the results. You see that it's taking the expression, evaluating the expression, and just saying pass or fail. So if you want to see a fail, let's say that we said 1 + 2 is 4. Okay. But let's do that. You see the same thing. You can see that it will return nil, the expression, and then the format expression, which we'll learn later on about the format language. That is the specifiers, the display specifiers that you can use. It will go ahead and do pass and fail based on the Boolean that's returned from the condition. But already we're noticing a lot of duplication. While additional problems. One is that it has this first function here, this test function, appropriately tells us if the entire suite has passed or failed. This one, it will give us the correct display results, but it does not give, from a testing perspective, a final Boolean value that essentially notifies users that their test suite has passed or failed, and they would have to go test by test to essentially look at what has failed and what has passed. Obviously, what you want is if everything passes, you want to see a nice true at the very end. But if it's nil, then you can go through and do a test by test inspection. What we can then do is we can say, fine, this is kind of redundant. Let's refactor this guy and create a function called return report result that takes the condition that we're passing, the result of the form and the actual form that we want to actually display. And what we'll do is we will go ahead and display that. So let's see. We just simply do what we did before. We use our format string from earlier. That we evaluate the form and we return the result. And what you can do is suddenly we're going to rewrite this guy as a defun, let's say, test plus again. This is our new test plus that we're defining. I now, just for my own, just so that you guys can see. Hold on one second. This guy, shoot. Okay. Right. No, comment region is what I wanted to do, not indent. New one now can just simply report the different results. We're just going to go through and, just type in this. Oh, pass in the same conditional. You're going to see where this kind of breaks down again. And let's, also do the same thing for result. +1, 2, 3, 6. And we call test plus now. Or what we expect it to do. But what you really want to do is be able to pass in multiple of these. And also, if you notice here in this function, we have some code duplication here, right? We take a piece of data, which is essentially, sorry, like this form, which is a conditional, and we are passing it twice. Once as an atom, has a piece of data that should not be evaluated, and once that is. We can actually go ahead using common Lisp macros, go and fix that. So if we notice that we have something like port result return value of in the form itself, you can see that you can actually create a macro out of this. It tells you that this is a piece of code that just can be generated for any set of forms that's passed in. So you could think of this as being a piece of data that's passed into a macro, and it'll generate some code for you. So what would that look like? We can actually create something called a check form that takes one or more forms, and then we can actually generate a piece of code that will literally loop through each form results of running this report result function. Let's see, what does that look like? If we run, let's say a simple case here, 1, 2, 3. Okay, we see that it took the condition, evaluated it, and returned it. Let's see if we could do multiple of these. Let's try. Say our minus example. You see that this is much easier to read, and we're actually still getting the appropriate display results that we want. And the difference changed from something that looks like this to something that just looks like this. Obviously, this is too simple of a case. We're like, okay, yeah, that does clean up some code. We have some correctness here that we can, we can leverage, and we can make sure that as long as the structure of the macro is correct and our evaluation order is correct, we'll be okay. But there's more to that, and the tutorial goes on, and talks about combining different sets of results, because obviously in our first example, again, we haven't fixed the issue of looking at the test results, and while we're looking at each individual test, if it failed, we want the end test suite to fail. We haven't actually displayed anything that will give us any sort of indicative indicator from our function call test suite is actually to fail. What we can then do is we can create something called that looks like sort of like an aggregator that will take the list of forms, and it will actually run through each form, and if any one of those forms fail, then it will false, and if one of them if none of them fail, it'll return true. So let's function that is called in here, and the book goes by this, and this is what I'm going to be going by, is it's called combined results. And all it does is, and I'll just paste a macro here that is generated, and we'll go through this line by line. For those who are new here, I know, and those who came to last meeting, I know we mentioned the use of certain types of were mentioned earlier in the book. that you don't necessarily need to really understand, and you need to know about them. This is one of those case for you when you're constructing macros that Common Lisp provides you, that gives you the ability to generate unique symbols for each variable that you are binding inside of a macro, because there's an issue when you're generating macros where if you use, and I can show this to you with a different example. Let me pull that up because that is actually a very important thing to actually understand. Because let me pull this guy down here. Okay. All right. The end of the previous chapter, but it does illustrate why this with Jensens actually here. In this example, we have two common functions, and we're creating an iteration construct that will loop through a essentially a range of primes within a range, start and end. And there's an issue with the initial macro that you would probably start with. It's a very naive attempt to actually implement this macro. The issue is end can be a form, that is a piece of code that is passed into the macro that's going to get executed every time the loop goes into. Obviously, you don't want to do that. That's wasting computational power. So what you may want to do is do something like this. You create an ending value, set that to end, and then just do ending value. So one of the issues that arise here is that with actually, I think I missed one thing. Just give me just 1 second here. Yeah. So what you want to do is you may want to start this guy here, because you don't want to evaluate it in the beginning of the loop. Obviously, one of the issues there is the fact that you want to actually start computing the ending value after the start. So you may want to change the order of this guy so that the ending value, the end of your initialization statement, and you check it every time. So that way, if there's a dependency between the start, you could check for that. But by fixing this issue of evaluation, we've actually incurred another problem, which is if we were to do something like this. Let's say that we create an outer scope function, all right? And we end up using the same code. Just because this is a macro is kind of like a syntactic extension, right? You don't know how it's implemented. By being able to, actually, let's start this at 0. What's going to happen here, if you run this guy, and let me just, like this. If you try to run this guy, you're going to end up seeing that end is considered, 1 second. There's a bug in my macro. All right, let's try this again. You'll see that ending value is actually never used. And the reason for that is if you do Control-Z, Control-M, you'll actually, let me take that back. You will band all on this guy using SBCTL CLTL2 and all. So see what's happening is it's taking the outer value and it's binding it, and it's getting overridden by whatever the inner value is actually setting it into, which causes it to cause error. It won't actually evaluate. So the way to fix that is the problem is arising because ending value is considered to be one type of symbol. It's considered to be its own unique symbol inside of the Common Lisp system. So symbols in Common Lisp are a very special type of object. And I'm not going to go too much into details. I just want you guys to know that because of this, naming is very sensitive. And when you're doing macros, the only thing you need to know is if there's computational results you want to hold within the lifetime of the macro, you'd want to compute that with a unique and give it a unique symbol. And there's a symbol generator called Jensens that does that for you. And we'll fix this macro for a moment, but I'm just going to show you that in the REPL, use, what was it? The symbol name? No, it's not symbol name. Hold on. Symbol, what was it? Should have been symbol value.
What are you trying to do?
Forgetting trying to show them how to get symbols when you try to pass in a string.
Intern.
Resolving intern.
Also, as a side point, if we're going to pause for a moment here, a few people have been having some audio issues.
I have not.
Yeah, is there? You know, if there's anything you can do on your end for that, or is it just, same setup as always?
Let me see. Same setup, but I could try a different microphone. Give me just 1 second. How does this sound? Better?
Well, it's more that there's audio skipping issues. So. And now we've
audio
got
skipping. That is out of my control. I can't. Yeah. I don't think I can.
Okay. I needed to bring that up. So.
I have a quick question.
No, thank you.
Paused. I can't see basically the bottom of your Emacs window.
You cannot see
it's behind everyone's pages.
Oh,
how's that?
If you've got someone's stream selected, like if you click on their icon in the bottom row, then up at the top there's an option for hide participants. It only shows up if you've selected a person, though.
Got it. Okay, thank you. All right, I'll go back on the mute.
Right. Any other issues? I do apologize about the audio. YouTube Live so far has been kind of good. I've heard some issues related to videos starting troubles, but we're working through those issues as they arrive. Have audio problems or okay. Oh, what was it? I was going to show you. It was about symbols.
Intern.
Yes, intern. Is it intern? No, it was not intern. Was it?
Intern takes a string and it gives you a symbol, the symbol named by that string.
That's what I was looking for. Thank you. Yes, it is intern. Intern have a certain type of underlying object model. What I wanted to show you is what they are represented. They are whole scale objects. So inside the common inside Common Lisp. So it's unbound. So let me take something a little bit that's actually bound. Let me do. yeah, let's just do this. Test plus. I do test plus. I should get what? Found it. Okay, this guy here. Control CI. Nope, it's not showing up.
You need to quote that if you want to get the symbol object and inspect it.
Thank you. That's what I needed to do. Thank you. So this symbol object, the symbol instance behind the scenes, if you look at the inspector, is actually providing us with several things. It gives us, the name of the object. Now, it shows that two things. One, that it is unbound and it is a function. Now, this unbound and it's a function is that the symbol right now is bound to a function in the function namespace, but you can use the same symbol as a variable. I just want to mention that just because, since we're talking about symbols in Gensim, there are cases where you're going to end up accidentally seeing somebody, using the same symbol for two different purposes, and why they decided to do that. But Common Lisp is a language that allows you to use the same symbol in a variable and a function. Now, going back to how we would fix this do primes issue, the way we would fix it is it's actually pretty simple. All it is you would create a Gensim in a let form in the beginning of your, call it variable name, and Gensim in the code generation. So basically, this guy now is no longer, and then you can leverage issues. And when you generate the code for this, and we could just take a simple example, this guy out, and I don't believe I need to do this, but just in case, and we do Control C. This does not help. Okay. TLQ macro expand all. You will see what's happening is first, before it even generates the code, it creates this variable. Where is it? It is in creates ending value name. All right, and ending value name is actually now a value that was the result of evaluating end. Instead of and it's actually a symbol of this form usually, of hashtag, some identifier, and some numbers associated with it. This actually happens so often. This need to create generic symbols with Gensims is a macro that literally just wraps all these variables, like in this case results, in a Gensim macro, saying what you essentially are passing to with Gensims is a list of variables that you want to create unique symbols for, and then in the code generation, those symbols. So this comma result is a unique symbol representing the variable that is being assigned true here. That's kind of cool because you don't have to worry about issues with like name resolution or anything, or conflict resolution, as long as you follow the rule of thumb for your macros to make a call to with Gensim to uniquely evaluate certain forms before you go and code generate part of your actual template, your expression template. Does that make sense for folks on here? Elijah, did I miss anything?
I admit I vanished for about a minute in the middle there, but otherwise it seemed pretty comprehensive to me. I mean, with Gensims is,
okay,
you know, it's one of the core tenets of macro hygiene, which I'm sure we'll get into soon. But you know, it's important to get used to whenever you need a local variable Gensim it. You know,
cool.
That's what it comes down to.
So we're actually almost done here. The only thing is that we're now kind of missing is so in our testing framework now we have, you know, a combined results function that we can now leverage. And how would we leverage it? And this is just going to, you know, take, you know, each of our results, and then at the end it will, you know, return you know, true and false. So let's see if that kind of works. What we're going to do is we're going to refactor this guy because we need to actually leverage combined results. We're going to essentially replace our macro template, and I'm just going to paste this here so you can see the difference. We're going to change our prog-end to literally just a call to our macro that will take the loop of all the evaluated functions and then tell us whether it's out true or false or not. So let's see how that works. We do check equals +1, 2 equals 1, 2, 3. And the result is not defined. I am missing something here. Yeah. Let's see.
Have you defined with Gensims?
I didn't think I mean I didn't have to define with Gensim, right? So
with Gensims
it's
is
part of
annoyingly enough not part of the standard library. It's part of Alexandria. So you do actually need to define.
It's part of.
Yeah.
Okay, hold on. I thought I loaded out. No, wait. Did I wait? I don't remember him asking me to in this.
He
book,
defines with Gensims in an earlier chapter.
He does. Ah, yes, he does. He defined it. Yes. Let me grab that. Missed this piece. I thought of this earlier, but so undefined. Hold on.
You need to redefine the check macro or the combined results macro, actually.
Yeah.
Yeah.
Okay. I should have just recompiled this guy entirely.
Yeah,
okay.
when you're dealing with macro recompilation issues, recompile the whole buffer. it just makes your life
just
easy.
recompile the whole file. It should have. That's usually they let go. So let's go through this just very quickly, folks. So this with Jensens Macro, which is actually
I'm sorry,
Alexandria, and I just use it so often, but I forgot that in the book he actually defines it. It's really
pause
just
for a
a
moment.
loop.
Someone wants to speak.
Yeah,
sorry.
Quick question. Sorry, is there a way to force interpretation versus compilation?
No. What do you mean by force interpretation versus compilation?
Like so to avoid that like macro problem because it's pre-compiling the function.
Oh,
That's why you need to recompile. Is there a way to just say, no, interpret everything that I'm putting in instead of compiling it?
Not portably.
Yeah, each Common Lisp implementation, Michael, has a flag that you would have to set to check whether or not something's going to be a compiled function or not. SBCL by default compiles everything.
SBCL actually makes it difficult to interpret things even. They're like the interpreter only works if you're like doing small forms at the REPL, and like the moment you step even inside a function like a lambda even, it compiles the lambda. Like because that's just how it's designed. It's designed to be a purely compiled Lisp. There are a few of them that are purely interpreted, and in those cases, you probably have it lazily expand the macros. But even then, the Common Lisp spec requires that every implementation have the ability to eagerly expand the macros, even when it's an interpreted Lisp, meaning it expands the macros ahead of time, because the compile file feature, it basically, the spec defines as the minimum number of things that an implementation needs to be do in compile file is eagerly expand all the macros. So every implementation needs to be able to do it, and so most of them probably will be, although some of them might have a flag that tells it to avoid. I've never tried that though, so I don't really know. The short answer is no.
Okay.
Okay. Any other questions? Let's talk about the stuff here. And can you guys hear me?
Yep, we can. Well, I can hear you anyway.
All right. Make sure some issues with my bandwidth. I was trying to fix them while that's causing some some issues with the audio from my end, and I wanted to make sure that there isn't any choppier. Okay. So we're almost there. The only thing remaining now is really like fixing up for result primarily like if you wanted to create like a test suite to be able to specify a set of tests, and then just say that this is going to be our test, and run through it. So one way of doing that is we can create this is certainly not the only way of doing it, but you can create something like a def var to specify your test name, and then you could then create a macro called def test that takes in the name. And its parameters, and generate a function that represents that test. So now, instead of defun, you will actually create a test by calling def test. Let's create a simple one that calls check on checking multiplication. This is test. And this will work the same as if you've created a normal test suite. So that's kind of cool. There's other things that you can do that the chapter goes through, that I do encourage you guys to go through in a little bit detail and try it yourselves. primarily things like, if you want to display the test suite, the actual test and the function that you're actually calling, you could do so. You could clean up the macros a little bit more, improve usability. But at the end of the day, you could see the design pattern that sort of emerges here. That's a little bit different than other languages. Other languages, almost often what you end up doing is you're creating a function. So after a series of functions, you are actually, each one will have a stack frame. You have to keep track some of the state that you want to pass into that, because you won't actually keep track of that when you return from the function. Whereas here, what we're actually doing is we're directly manipulating, essentially, from compilers, where the abstract syntax tree, or lack of a better analogy, I'm sorry. But there are advantages and disadvantages here, but at the end of the day, the code that you're seeing is as declarative as it can be. If you look at the final product, which is shown here, I did a nice job of. Let me just show that here. This 26-line file that summarizes the entire test suite. You could see that it's not a lot of code, but this is a clean API that anybody who wants to write a test and doesn't want to leverage a thing, they could just use this, and it'll give them as decent and displayed results as possible. And it declares the intent of the code. It has a form of documentation. So what this chapter, if there is something to get out of this, is not only the practical experience of creating some macros and being able to design this framework, but is to understand that macro design, much like language design, is, I actually say, is the same in some extent to API design. You are declaring your intent of your functions and your data types, and the domain in which that it's actually going to be acting upon. And you're allowing your users, especially those who have some expertise in that particular domain where you're creating the language in or API in, to leverage their intuition to declaratively define what they want to compute, and not go down into the low-level nitty-gritties of the language and explicitly spell out each and every step and every branch that needs to be done. If there's ways that you can extract those into a syntax that can be just leveraged, that's a huge win. And what's funny about this is recently some proposals are being brought to the table in other languages that doesn't completely provide this type of feature exactly, but it does try to encompass this idea that syntactic extension is just, another design metric that could be as part of the developer tool set. In Common Lisp and Lisps in general sort of use that approach to define their entire library. Any questions?
Yes, sorry. So the one question I had about the chapter was the defvar. When he was in the middle of writing the code, he was at the point of where he was refactoring, and then he's like, oh, we need to pass this additional information from function to function, and it's that happens often, but with Common Lisp we can throw it in this in this global, and then we can change it as we go along, and as we pop the functions back up, it it restores the previous value, and he's like, it's perfect for that. But when he was doing it, it seemed like if you were in the middle of refactoring anyway, a better design decision might have been to just pass the information along in the function. So it didn't really seem like that was the purpose for a defvar. I thought a defvar was more for almost like global configuration information that you might want to override at some point. So I didn't know if that was just something that he did to just show how you can use it, and it was actually a bad design decision, or if that's the way people usually end up writing things in Common Lisp because it seems like he's polluting the global namespace with stuff for this little test suite that doesn't need to be in there.
Well, so there are a couple of design decisions that kind of go back and forth when you're going through that sort of system. The first one is that this is all packaged, namespaced, I guess you could say. So that the test name defvar is, I guess you could say, local to this library. So in that sense, it's not polluting everybody's global space. And also, it's not leaking information because of the way the dynamic variables work. But in the other sense, in this particular example, it may have been simpler to just pass the data down as a separate argument. The case for this really comes in when there might be intervening function calls that you don't want to change the API of, but you still want to be passing data down the stack. And in that case, that's when this really becomes valuable. And so I don't know if the value really shines in this particular example, and it may have been better, you're right, to switch over to passing it explicitly as arguments. But when you have state like this, encapsulating it in a dynamically bound variable like that is a very flexible way of ensuring that it's always around, even without having to include it as part of the API of everything.
Right. I would actually add one addendum to that. I agree with you in the sense of taking another approach, but in this case, I think let's say that you wanted to run this on multiple threads, try to run a suite of tests independent of each other. With unit test suites, you can do that. And you can leverage this this defvar because it's now thread local storage. It's not actually it's no longer global storage. So I don't know if that was his intent to actually go do that, because I'm sure that this is a simple contrived example. But I could say that there are some benefits to this design from that standpoint, because now you can run independent tests a little bit concurrently rather than sequentially.
Okay, is that something that'll become like more apparent as when to make that decision versus when not to?
Yes, as you play around more, you will definitely get a good sense as to when this would become useful versus not useful. And there are cases where it's where one is better than the other.
I think in general, the case for defvar comes in when you have places where a function is taking an argument purely to immediately pass that value to a bunch of other things that it's calling, and is not actually doing anything with the value itself. And if you have that all over the place in your API, it's better to refactor that data out into something that's dynamically bound, so that parts of your API that don't actually care that that data is being passed down don't have to worry about it, which makes it less likely that you accidentally forget to pass the data around somewhere, or it makes it less typing, and yeah, as you get further along, you'll see cases where that becomes exceedingly useful.
Yeah. All right. Yeah. That's good, because I know that it's a common problem when you're doing stuff in other languages, but it also at the same time seemed kind of hokey when he did that. I was like, oh, I don't think I would throw it in a global, but that's why I wasn't sure.
It's not a global though. That's the important thing, because and I think we just haven't talked about actually how dynamic variables work yet, have we? I can't remember.
We haven't really touched base on it, primarily because the book doesn't touch base on it too much. He talks about it a little bit, but he doesn't really touch base on it in as much detail as in other material, like say ANSI Common Lisp. But to sum it up and I'll bring up an example that I actually brought I actually posted I did for another talk when we had this so in I actually wrote the script that shows some examples of different features of Common Lisp, but the one thing I wanted to show was in special variables. Hold on, dynamic. Okay, so dynamic variables are more like, I would say the closest thing that I can give an analogy to are more like environment variables in an operating system. Like when you run the shell, you have shell variables, that when you invoke a process, when you actually execute a program in that shell, it copies that entire state environment and then sticks it into the process before it actually gets executed. But then after the process gets executed, if you change one of the shell variables, the process has to be restarted. It doesn't actually get the update. Much in the same way, dynamic variables, when you set a value to them and then execute some sort of context that has that variable bound to a value A, it can later on internally be changed to a value B, and the internal context where it's referencing B will go away and it'll become A again once it exits that context. So that scope has essentially shadowed that dynamic variable. So one example of this that I actually have, or I thought I had, was let's create one. Let's say that you have something, our test name, guy, and we named it hello test. You can actually internally, actually, what, let me just say this is no for now. And then in one case, you can bind this guy to say, hello test. And internally, you can call this guy here. And you can create another one that binds it again to another test. And then print this guy again. And when you do this in the REPL, let me just go to my REPL again. When you compile this guy, you see here, what it is in the scope, at the top scope, it is hello test, okay? In the inner scope, it got rebound. It's shadowing the previous variable. So now if you go and change this guy and set it up or increment it or do whatever with it, it's bound to another test for right now unless you change it again. And then when you exit again, it's rebound to whatever it was in the outer scope.
May I make a suggestion?
Yeah, sure.
Write a function print test name that doesn't take any arguments and prints the current value of test name, and then replace all your calls to print with a call to print test name. Okay. That'll really show that it's dynamic context. That
Test name print. Oops, this guy. That's right. I forgot to compile those guys. All right. Now, just show you guys this again. And just clear up my buffer here so you guys can actually see this. So now what we're doing here, what Elijah is suggesting in here is that we have this inner scope in this function that's just printing the current test name, whatever it's bound to, okay? We're binding it initially to hello test before calling the function, all right? And we're rebinding it to another thing before we call it again. And finally, once we exit that scope, we should get whatever the original bounded variable for test name is here. So when you evaluate this function, you will see that this is the case here. all we're doing is referencing a pointer to some global context that can change based on the scope of the context that it's in. There are advantages and disadvantages of doing this shadowing. Again, the main things that I've seen it being very useful for is, as you said, dealing with configuration for different types of contexts and passing those configurations to separate processes or even separate threads. But there are other cases where this kind of shadowing is useful, but they're more advanced. The one that's more blatantly obvious is the concurrency one that I can immediately come to my mind.
I actually do have another example for this, and it has to do with how the Lisp printer works. The system. Oh yeah. You know, so if you when you call the print or to any of the printing operations, and you know, if you're not just giving it a string, you know, it has to convert that to a text representation somehow. And it turns out there are actually a lot of dynamically bound variables that control precisely how this happens. And so you can actually have a lot of fun with things like print base, for example, which defines the number base that the printer uses when printing numbers out. So you could say define some function that prints out a list of numbers and then wrap a call to that function saying let print base be 2. And now when it prints out that list of numbers, each of the numbers in that list will be in binary. So would you mind throwing that up, or do you want me to share my screen and show that?
Could you share that? Sure. I didn't catch all that.
Let's see, where is that? Share screen. Yeah, so here I am, 3. Everyone see my screen now?
Yes.
Okay, awesome. So there's this neat little variable called print base, which controls what base the common Lisp printer displays numbers in. And you can actually assign to this in the REPL, although most people will probably yell at you if you do this. If you note, this printed out 1, 0. And now any other numbers that I type in here are going to be printed out in binary, because I've told the printer that when I want it, you know, when it's told to print numbers, print them in binary.
Could you enlarge your screen, if you don't mind?
Oh yeah.
Thank you.
That better for everyone?
Much better. Thank you.
Awesome. So as I was saying, you can assign to this print base variable and such. I'm now going to have a fun time getting that back to the value it should be. 1, 0, 1, 0, if I remember. Oh, no, I haven't changed the read base, so I can just type 10. I forget that sometimes. The thing is, it always prints out 10 when you change the print base, because you know it's the base you're printing in now. Anyway, so let's say I define some function that, you know, doesn't really matter what I call it, and what it does is it prints out some list of numbers. 10, 20, 30, 40, 50. Right? And now if I just call foo, I get, you know, those numbers back out like you'd expect. But if I let print, oh wow, that gets really funky. What if I let print base, I need to take that down just a smidge so that things don't keep breaking. If I let print base be 2 and I call foo, you'll notice that now the printed one comes out in binary, but the one that gets printed out by the REPL, the read eval print loop, is back in base 10 because I locally changed the print base to 2. And so this propagates to any calls to print that happen inside this let body. But then when this returns the original list, because by the definition of that, I'm just going to create a it's right there. You'll note I've just restarted my laptop, and so everything is being auto-loaded in. So I'm, you know, things lag out every now and then. Where is that? There you are. Definition of that. We just take that over here, scale that up a little bit so people can see. So, you know, we have this function here, and I'm locally redefining the print base to be 2. And so now this call to print that happens, when it prints it in base 2. But when it returns it, and then that return gets propagated all the way back out to the REPL itself, that's now outside the scope of this let binding. And print base reverts back to 10. And we get the list printed out in base 10. There are actually a lot of printer control variables. Going through all of them will take a while. They're all useful for little things. But the point is that because the print control variables are dynamically scoped, meaning they affect any calls that happen inside the scope of the let binding, no matter how far down the stack they are, you can control the printer at a very high level. You can redirect its output. You can, change how it, prints things out. So another thing is that I can go over here and do, I think it's print readably, if I bind that to T. Oh, funny. That ought to add, I'm doing something silly. I'll find it out eventually. Anyway, I'm forgetting how some of the printer control variables interact, apparently. Anyway, the point is that that you can control the processing going on in the printer dynamically for any functions that get called by any functions that you call, and redirect where output goes, and etc. in this very high level way. That's one of the basic benefits of having very dynamically bound variables like that around.
It really makes interactive debugging kind of nice, because places where you actually do need to leverage it, like especially for your environment, your programming environment, you will use it, just like in the case that Elijah mentioned. But in terms of your actual code, like will you use it in an application? You have to look. It's a case by case basis. I'm not going to say it's completely useless, and I'm not going to say it's like a very critical thing in the common Lisp environment. It really is depending upon what you're doing as to whether or not you will use it. But Notion, if you want to understand dynamic variables, I say that is the closest analogy I've ever come up with is think about them like process environment variables, like shell variables, for configuration. That's about, you would then understand, at least, when you invoke a process, how shell variables get copied in. That's sort of how dynamic variables are copied into the context, the actual executable context. There was a comment actually by Michael that I like want to also say about evaluating. What I like to do is to keep the original binding unbound, so I can notice if there is a problem. Hey, Michael, could you just quickly type up what you mean by your comment about evaluating test name in the REPL to initially to null?
I think he's just referring to that if you're only ever doing let bindings, you never affect the outermost value of the variable.
Okay, thank you. I just wanted to make sure if that was the case. I wasn't sure. It just
yeah.
Okay. Yes, that's right. That I in general, when you're creating your configurations, this is probably one of the few cases where, when you're talking about configuration, where I would actually suggest using def var versus def parameter. Because def parameter is a default configuration sort of situation where you're required to provide a value, but def var, you don't necessarily need to provide a value. Only when you're using it would you want to wrap it around in a let context, initialize it, and then leverage it, so it's bound to a value when it's actually used. But in going back to the topic of dynamic variables, it's just really what I said earlier. Think about them as invoked on a context by context basis, and then think about the bindings at that innermost context where it's actually leveraged, and it will help you a lot. Any other questions, comments? So for the new folks in the chat, I just like to ask, have you guys had any experience with Lisp in general, or have you is this your first Lisp? Because I'd like to convey some misconceptions, primarily from the Clojure guys, especially because some folks believe that that Common Lisp doesn't have like currying and all that kind of stuff. Those are available through third-party libraries. And when we get to that, when we start actually exploring what I would consider the de facto new Common Lisp standard library, which is the set of third-party libraries that almost every project that you probably encounter nowadays will be using. One of them is Alexandria, and it actually has a lot of the functions that you would normally take for granted in Clojure and other languages like that. Let's see. So there aren't any questions. I'm just going to, say some final comments, and then we can. Just like, right. I'm going to just say some final comments, and then some future announcements to just consider. One thing is I am trying to look for a starting project for you guys that we can go through bit by bit, so you can get some actual understanding. While there are a lot of good projects that are being presented to you through Practical Common Lisp, and I do encourage all of you to keep going through them. It'd be kind of fun to actually do something end to end, and show you how you might be able to compile it as well, leveraging some of the newer tools today, such as Roswell. So project ideas and proposals and stuff that you guys want to see, please let me know, and then we can actually put it in our study group timeline. If there's something that I'm willing to get out of just throw in as a side note while we're even working through Practical Common Lisp, I will do it. Other things I want to mention is I noticed recently, I don't know if you guys have used this, that HackerRank, actually a lot of their problems allow you to write your solutions in Common Lisp using SBCL. So if you guys want some practice writing simple functions, you can use that too as well.
Oh yeah, I've indoctrinated a few people by having them go through HackerRank stuff in SBCL.
It's really, really fun. I think you guys would really end up picking up a lot of the concepts pretty quickly then. So HackerRank is available to you, and as well as I think I noticed Project Euler also is another site that you can get some nice math problems to write Common Lisp programs with. But again, the game jam draws near right now. I'm trying to figure out what kind of graphics tutorials to show you guys. So I hope this week and last week were good overviews for macros for you guys. Oh, thank you. I'm going to start announcing it as it goes through week by week, but April 13th is the Lisp Game Jam, folks. It is a week-long game jam. It's a beginner mode. I know it's a little early because it is end of January, but it gets me excited to talk about the game jam. We'll do some game programming hopefully in this study session, so you guys can see some really cool stuff in it.
I sort of feel like I guess he probably might not have a microphone, but I mean, if anyone's going to be talking about the game jam, it really ought to be Michael Ciano. He is on the call after all.
Yes, and Michael is actually typing in exactly the script that I'm hopefully putting in.
Yeah.
And Game Jam, your organizer, is on the call. He is been a very active organizer for the Game Jam for years. And hopefully, you know, as we get closer and closer, we'll start bringing up some graphic stuff to you guys, so you guys can join in and have some fun for a nice 10-day adventure. But I want to leave the floor to you guys, the beginners, the intermediates, anybody who wants to at least bring up questions, comments about, you know, other languages with respect to Common Lisp that you guys want to at least hear some comparison about. I am working on a deployment tutorial right now. It's been a little difficult, but I'm hoping that after we're done with Practical Common Lisp, I will bring that up to you guys too as well. Any questions, any final comments from the folks that are on the call?
I have a question about other languages. I think I might have chatted with you on the phone about this, Ron, but recently I found a video from a woman named Joyce Xu, spelled X-U, who is now at Stanford, and she has written an article or two on Medium, and also has at least one video out on YouTube talking about the use of Clojure as with machine learning. And she describes it, oh, well, you know, there's I think it's pretty intuitive actually, that there's an overlap between functional programming and machine learning, since a lot of machine learning is basically, hopefully, what do you call them? Combinatorial, you know, taking one combinator after another and linking them together. That seems intuitively up the alley of functional or functional capable languages. And she seems to think that, or at least coming across that, Clojure is a great one for that. And I'm not sure why Clojure would be better than any other Lisp. And
I can make a quick comment on that, just because I have seen other folks, not specifically that article. I have looked into machine learning in Lisps in general. CLML is a machine learning library that's available for Common Lisp. I haven't actually had a chance to really experiment with it recently. It was a recent find. And there are other languages, like there's a Common Lisp distribution. I think Scienir, if it's still actually active, has done quite a bit with numerical processing, and of which one of the things that they done was with machine learning. But in terms of Clojure specifically, I think the reason why a lot of folks have been promoting that over other Lisps is primarily because TensorFlow's API its Java API can be easily used from within Clojure. So you can leverage TensorFlow directly within Clojure and then use the beauty of other facilities in Clojure to get something that's really, really nice in terms of a good functional design that's leveraging some of the deep learning features of that library. But other than that, like TensorFlow, MXNet, and all those other machine learning libraries are available in Java, there's no difference from what I can see from leveraging Clojure versus, say, Common Lisp or other Lisps in general, like Julia, or even Dylan for that matter, if you really want to, you know, use an Algol style Lisp that's available for you. That being said, if you want to get started quickly, leveraging Clojure is not a bad idea, because at the very least you are writing, you know, some scheme style Lisp and trying to leverage functional programming as much as you can when you're designing your system, and hopefully you would do some meta programming where appropriate. But that's only because TensorFlow isn't available for, as far as I know.
Yeah, machine learning is always a little funky because it tends to basically come down to, do you have high quality libraries that make working with it easy? Or are you willing to write them yourself because they're a royal pain? I've tried. So, you know, Clojure has a lot going for it syntax-wise, like data literals, but when it really comes down to it, I don't think there is anything in particular about Clojure versus Common Lisp specifically that would make either more suitable for machine learning. I think that, you know, I'm going to hazard a wild guess here, and there's a good chance that I'm completely off base. But in a lot of cases, you'll find people talking about a particular Lisp independently without discussing that it might be applicable to other Lisps, because they're either only experienced with that particular dialect, or because they're talking to people who are from outside of the Lisp community, and it doesn't matter a whole lot that there are differences between the Lisps, and they're using a particular Lisp by example because it's familiar, or a variety of other reasons like that. But I can't think of anything in particular that would make Common Lisp unsuited for functional style machine learning APIs. You know, I've actually hazarded a little try at automatic differentiation stuff, which was fun but a pain. And really what it comes down to is not just good library support, but specifically GPU support, or rather parallel programming support, because the only way that you're actually going to get any leverage out of your machine learning library is if you can parallelize everything, and that just gets all kinds of complicated. And so, like, these days, I point people at TensorFlow when I can, no matter what language, because, you know, it is a high quality library for doing this kind of stuff. And honestly, just having a high quality library for it is more important. I don't think there's anything about Common Lisp that makes it less suited for having such a library. But as I said, I don't know if it has one. I've looked around a little. I haven't spotted anything particularly effective on the spot.
There isn't much in the machine learning world that I've seen, in my at least own exploration for machine learning libraries available for Common Lisp. There are libraries that are, say, for C, that one could write a wrapper to expose it into Common Lisp. But in terms of actually like native Common Lisp libraries, they're very slim. And I think part of that is because some of that just either were projects that never, taken off the ground. Like one example, like I said earlier, was CLML, which I've seen out in the while back, but I don't know how complete it is. I mean, there are a lot of things like that that are available, but haven't really taken off beyond a certain, niche set of problems. But I quote, I think, a lot of open source developers when I say, oh, pull requests are welcome. If you guys have an idea, implement it. Let's try it out. I mean, we'll have some fun, and, even if it doesn't, may become the greatest library that's available, at least there is a library that implements some of the basic algorithms, and learn something.
And as one other note, if we are talking about graphics card or just parallel programming access specifically, that is one area where I suspect that Common Lisp would actually be more suited than Clojure, not to start dialect wars or anything. Right. But Common Lisp has a very mature foreign function interface, and actually there are wrappers around both the CUDA and OpenCL libraries, although I haven't done a whole lot of work with them myself. I've done a little bit of CUDA in C++, and I've looked at the CUDA library for Common Lisp, and it looks like it'd be functional enough that you could definitely leverage the graphics card for Common Lisp machine learning if you wanted to. Right. So and that's one of those things that Clojure has to rely on a Java library for, I guess you could say. I mean, you're relying on CFFI, of course, for Common Lisp anyway. But if you're talking specifically about the ability to control the low-level details that make building such a system, possible and efficient, Common Lisp is actually pretty great for that. And actually, as Fiano mentioned, Michael Fiano mentioned in the chat, CL is also great for GPU programming. There are actually a number of really great wrappers around, like graphics programming libraries for Common Lisp as well, because you can take low level abstractions and really make them nice to use without sacrificing a ton of efficiency. So
I think that that is a space where there's a lot of room for experimentation. Like Amphiano and Elijah said, there are great abstractions available for you, a lot of tools for you to create these kinds of libraries. It's just that there hasn't been a lot of work put into creating some of them right now. Primarily because there were other aspects of the common Lisp system that needed a little bit more work.
Quick, I don't really want to start making tons of shout outs, I guess, but there are a lot of nice. There's a lot of nice experimentation going on in the Lisp game space, actually.
Exactly.
And so
I'm saying that it's a perfect ground right now.
Yeah.
Fertile. Graphics programming especially has made a lot of light years. I mean, in terms of the libraries and quality of libraries available for you to create some really great games in Common Lisp. And has a side effect. They also help create some stuff for generic GPU programming, like you mentioned, either through CUDA or through OpenCL. Concurrency has, things like Bordu threads, LParallel, CLNPI. There's a lot of them. But, those are topics that we can certainly, bring in due time as we go through it. So finally, next week, we are just going to breeze through these guys. The next 3 chapters literally is about collections and basic data types. So 10 through 12 is what I'm suggesting that we go cover next week. Obviously, we can cover more. We can cover less. If there are other topics that you want to discuss, again, I'm usually on the Lisp Discord server. I'm available on Slack almost all the time, either on Tech 404, the functional programming Slack, or even Closurians if you guys are on Closurians, where the Clojure Slack channel.
A lot of noise on that Slack.
Yeah, there's a lot of noise. I know. But the Lisp Slack channel, the Lisp channel on the functional programming Slack is very quiet. It's usually me and the arch Lispers arguing it. So please join us. We are there usually just talking about stuff. Bring out your project ideas and bring up your creativity. If there are questions that you guys have, I'm more than available to answer them. And let's keep going. Thank you guys for joining. Until next time, same bad time, same bad channel. I will talk to you guys later.